The World Skeptics Congress, Paranormal, Supernatural, Fringe Science, Pseudoscience, and How It Really Is. Berlin welcomes you.
Next talk, I'd like to introduce Gerd Antes. He's a mathematician and head of the German Cochrane Centre at the University Medical Center in Freiburg. And he is one of the pioneers in establishing evidence-based medicine in Germany. Gerd Antes and I have actually met for the first time in 1995 when I was a student working in his group in Freiburg. And it was my job to hand search a German journal called Die Klinische Wochenschrift for clinical trials that had been published there. And so I looked at every single page of the Klinische Wochenschrift from 1995 back to 1949. I had to figure out if the clinical trials that were published there were good trials or not. As we know now, there's a bunch of criteria which make a clinical trial a good clinical trial. So this taught me to have a very critical view on data. And so I think I can say that Gerd Antes had some impact on me being a skeptic today. So it's my pleasure to introduce you.
Let me add that she did a marvelous job. My biggest challenge when I accepted this talk was how to avoid to repeat Jürgen Windler completely. So I tried to get around what he told you. And yesterday I thought I should have invented a lie to get the first slot. Then he would have been guilty, but now I'm here. So I'm running through these issues and take a more kind of bird's view. And I will tell you when I really repeat things. So, for example, let's start with the decision issue we ended the last talk with. Let's take a patient here, call him Neumann or Newman, whatever you like. He sees his doctor and gets advice, follows the advice, and in the end, he gets a result, clinical outcome. The big question is, what would have happened if he had done just the opposite? Means do nothing, use a comparator, standard treatment. The big question is what happens here. And of course, for two reasons, it is not possible to go that way. First, when he gets the information here, it's too late for him because the disease is already over. And second, he doesn't have a zip to split into two parts. So the whole thing is a fiction. And all we are talking about, and most people forget that, is trials or studies are a replacement, an approximation for this mechanism to think about what would have happened if. And this is the first repetition of your talk. You remember the citation of Stephen Zen, when he said the citation, what would have happened and what's the comparator? And if you then go through how you do this, how you design these trials, then you see all buzzwords we have already seen. So you have to need a comparison with a parallel group at the same time, because the patient needs a comparator at the same time. You need a similar structure, and you can completely map this to the buzzwords, to the pillars we have seen before. And if you then go into technical terms, then you end up with prospective trial designs, randomized, concealed, you remember the word concealed, treatment allocation, blinding, and intention to treat. These are the quality indicators of randomized controlled trials. So that was a repetition of what we heard before. Coming back to the consultation and the decision making, the question mark should have been removed, and we need, and what we now call in modern terms, a shared decision-making process between a doctor or anybody else giving advice, can be the pharmacist or friends, and the patient. And this should be consistent if the system works. This is called, if you try to Google that, counterfactual thinking. It's very complex to model that. For example, in Harvard, there are institutions where these things are modeled, but for practical use, this is, I would say, too complex, too mathematical. The determining signposts are bias and play of chance, randomness. So these two issues, and it's so simple as I say it here, are really the signposts who determine the whole process, and all we try to do is to control these two error sources. And in principle, if you think about it, if we would live in a what's the English word for that? Totalitarian. Okay, you know what I mean. So everybody has a number, and you can sample across the world, then you could fill these two groups, not using the mechanisms we have heard before. And this is kind of approximated on different levels. If you now look at how this is done, you try to find trials which are informative, for example. These are now different studies or trials. Then you extract a measure which shows you the difference, and then you kind of summarize these measures for a decision base. There's a synthesis. In principle, you could also disentangle the trials, go back to the patient level, and then analyze this as one trial. So this is called an individual patient data analysis, IPD. This is more and more approximating this global picture where you go really back to single patients. And this looks, well, as an unnecessary exercise. It's not. In many cases, working only on the literature base is very, very error-prone. And one example, historical example, where you see this is tamoxifen. You may know tamoxifen after breast cancer. And this is, I think, the most convincing example that under certain circumstances you should go that way. You see here in life studies you work on the base of person years. It's a huge amount. It started in '83. The last study meeting was in 2011. And I think nobody has calculated the investment, the overall investment. It's many, many millions. So it's a huge effort to get the result. And one reason why we are so clear what we have to advise women after breast cancer is this base. So we really know what we should say, in contrast to many other circumstances. And this has been known, this compromise here between IPD, very costly, versus this much, much cheaper approximation has been known since this article, for example, 14 years now, and that's where we are. So we are always between these two extremes, working cheap, but much more risk of bias, or here with much less results. And this is the big picture. If you do that, this is called a forest plot. If you summarize on the literature base results, this is just an example, thrombolysis after acute myocardial infarction. You see the trials here, about 25 years. These are the single trials. And this is the summary, the synthesis, the meta-analysis. And that's a clear distance from here to the neutral line, which says no difference. And so here the result is clearly, you should do it. What you see here is really interesting, the enormous heterogeneity among trials who all claim to do the same. And also, if you look at trial sizes, so for example here, two so-called mega trials, very, very big. This group here is really good to convince the ethics board to do a trial after 36,000 have already been included. But if you look at this argument, why should anybody do this small trial? The same question applies to the big one. Why should this big trial have been conducted after already 20,000 patients have been included in the whole process? And the answer is not simple at all. I come back to that point. The trials you see here are a selection of these increase of almost 20,000 per year we have now. These trials are those trials you find RCTs in Medline. Currently, we have an increase of about 20,000. And the question is now, what is reliable? If you see such a picture, is this a reliable selection? And how do you deal with these overall results here? And the aim is to generate a mechanism which allows you to get access to all relevant data. That means all relevant participants around the world. That does not mean that you reuse them in the end, but this is the ultimate objective. And the way you do that, now focus on questions, is you always go through these 5 steps. So that's a general framework in evidence-based medicine. You frame a question, you search, you assess the quality, you summarize, and you interpret the findings. And if you try that, you run into trouble. So in principle, this is a technique, for example, the institution of Jürgen Windeler is following. This is in principle the same, that's another example. And you see, again, 15 years, an enormous number of trials. This paper here is very readable, and the argument in this editorial in The Lancet was, you should have stopped here. And the basic argument is that this confidence interval doesn't touch this line here at this point. Statistically, theoretically, this argument is wrong. I don't tell you now why, but that's too complex. But in principle, we have to agree, and that's one thing I wanted to convey, is that there's no worldwide, no accepted stopping rule. So the whole world who makes decisions is working on very muddy ground. That means we have to come to obstacles, and this is the consequence of what I've shown you before, an article which appeared last year, which looks systematically of how far back are trials cited when you plan a new trial. And what you see here is really striking examples. A median of 2 trials was cited, no matter where you were. There's another citation here, about 25% are cited. That means, going back to this example, means wherever you are, researchers here planning a trial, they look back not more than maybe this little distance. So this is a kind of a loss of your whole brains, of the whole community after a certain while. So if you want to read something about that, go back to that paper. I make available my slides, so if you want to see the citation, it's very simple. I come back to that in detail. If you look at the bigger picture now, we are always living in 2 worlds. One is the world where we generate evidence. The other one is where we use it. And there are, of course, different stakeholders. So the classical approach, evidence-based medicine, is, of course, coming to physicians. But, of course, all other groups are very interested in doing this. So that's the evidence generation and use. And we have this barrier, and my work life more or less consists of thinking about this barrier, because we know there's a lot of progress. So all the information is eventually going across this border, most people think. But unfortunately, of what is started here on the trial level, 50% is disappearing and never arriving here where people expect this information. So the modern term for that, on all the problems around it, is knowledge translation field. The knowledge translation field. Very simple paper we did is we just followed the ethics approvals of our ethics board from 2000 to 2002. And what you see here is the publication rate now, today, is 48%. And I would have betted 200 euros or more that we are somewhere between 45 and 55%. And if you look at the bigger picture, for example, in this case, this is a very large study published in 2009 in PLOS Medicine. And if you stratify the information you see here, if you look at countries, if you look at the size of the trials or the phase or who funds it, industry or overall or non-industry, there are differences, but they are not very big. Overall, worldwide, 50% of what is started is disappearing. And that's a very strong message, actually. And it's amazing. Many people know that, and nothing is happening. I will show you in a second. A few words about the terminology. Publication bias is probably well known to you. Publication bias is simple. A trial is just not published. But the current modern information theory speaks about two layers or two levels of publication bias. And the second one is what happens between the planning and the publication if it is published. And the level of spin in here is probably much more harmful than not publishing whole studies. Because here it's clear, it's not published. You may not know it, but it's not published. In principle, it's clear what happened. Here it's not. For example, if you have ghostwriters who are very good in spinning, then the whole message you have planned in the beginning is distorted to the end. And it's very, very difficult in some cases to detect that. So the modern term is selective reporting on trial level or within trials. Is it harmful? Well, the answer is very clear. Yes, because it distorts the... If I had pillars, I would now take the pillars, the 3 pillars of Jürgen Windler, and kind of shift them like that. The whole ground is kind of moved in one or the other way, and even if you do a perfect job later in a guideline group or in an HTA group or in a systematic review, you're bound to be wrong, and in many cases you don't even notice that you're wrong because you don't discover that you are starting on the wrong ground. And there's no way around it if you don't know that. And this is not restricted to medicine. This is true all over science. But in medicine, it means, of course, damaging patients. 2 examples. One, very current, Tamiflu. Who does not know Tamiflu? Who has taken it? Oh, you don't know it, okay. Who has taken it? I don't believe you. It's very, very common. And if you go to your doctor in winter, you're very likely to go home with Tamiflu. Are you not? Okay. You will see that you should try to avoid it in a minute. There's 2 indications. One is individual therapy. So if you seem to have influenza, or if there is a pandemic situation, then Tamiflu is the name. And this is very recent now. January this year, you see here, a Cochrane review was updated, came out here, and there was a lot of noise around it, especially because the authors did not rely on the literature, but they went back to the trial reports. So they went back to the original trial reports of industry. And this is how this number here came up. And in the whole process, what is very clear now is that still now, today, more than 60% of the patients included in the trials around Tamiflu have never been published. Especially the big one here. This has been finished around 97. Till today, not published. Side effects in the publications, which you discover in the trial reports, not published. See these sentences here? This is an interview in the NZZ, Neue Zürcher Zeitung, very influential. What you see here is the arms of those, that means the influence, who want to kind of avoid transparency are very long. And then we have a very clear description of this. This was also in New York Times. So there's not much doubt about it, but nothing is changing. And the most striking example supporting that is the Parliament in Bavaria. There was a discussion about 7 weeks ago. What you see here is the opposition asked the question, the government had to answer whether they want to replace Tamiflu because they are running out of date under the pandemic plan. What you see here is the answer is very inconclusive, and what will happen is very predictable. They will refer it to the federal government, and they will refer it to an institution, and the institution will refer it to WHO, and then they will rumble on as before, and it's a lot of money. So for Germany, this means replacing the current stock on a level around 200 million euros, and this year or next year. The other example is, very brief description here, is a huge trial. Here they say it's the biggest or the largest RCT ever, including over 1 million children and you see here the indication, deworming trial. This has been finished in 2005. Until now, it's not published because authors are not interested. They don't like the results. And this is one of the most famous trial group in the world, in Oxford. Yeah, this is a letter to the Lancet. You see here, April this year. There seems to be some movement in this now. So, for example, this is the umbrella organization of, in Germany, for example, Deutsche Forschungsgemeinschaft, so that's the European Science Foundation. This forward look is very readable because all these things I've mentioned here are addressed in this forward look. And especially, we spoke about antidepressive drugs, I think in the discussion before. Very explicitly, there's one article which estimates that there's an overestimation, this typical over-optimism in antidepressive drugs, around 20 to 50%. Activities against this whole process is first, try to register trials when they start, develop incentives for reporting and penalties if you don't report. One very powerful tool is if you publish protocols, then you have at least the opportunity to see what was planned originally and go to the public, because it's a huge waste. If it's based on tax or even if it's based on pharma money, it's a huge waste. Billions are wasted by these processes. So this is the executive summary of this European Science Foundation. Forward look, you see here just one item is registration. If you go to the 2008 Declaration of Helsinki, in these two paragraphs you find registration and publication addressed. And one practical development is a worldwide network of registers where you have registers on a local level. This is the German one, Deutsches Register. And they are all pulled together by WHO and accessible through a portal. So this is working now. You see the web address here. You can go there. It's also in the US law. You see here 2007, an FDA amendment, register and report results of certain applicable clinical trials. So trials after phase 1, so phase 2 and phase 3, are legally bound to be published and registered. And this is the development in Central Europe, Switzerland. That's a federal law for research in humans, which has passed the parliament last autumn and will come to power next summer. So summer 2013. And they, for example, they have this as a very simple paragraph. You have to register. Not only drug trials, but the whole scale of trials. Quick look at Germany. See here, trial registration, the drug law amendment 2011 simply doesn't exist. Although there were two parliamentary hearings, and everything was written up in a perfect way. Why is it so important to know of current trials? If you look at a systematic review where you pull together, in most cases, quite a number of small trials, what may happen, and we have now many famous examples, there's a big ongoing trial parallel of your situation. And the most famous example now, I think, is the PSA test for detecting prostate cancer. And if you ignore this, you do this here, then you will have a clash very soon. Because as soon as this trial has been finished, it may overturn everything you have done before. So in this case, for example, these two trials, the two big trials going on now, they are the order of magnitude 150,000 patients, each trial. So no chance, whatever you do here, forget it, don't do anything, wait until you're here. Who is guilty? Most people like industry bashing. This is far too restricted. So this is a fairly complete list of the culprits. And I've shown you that they are very guilty because they don't generate the laws. Universities and faculties are very guilty because they don't enforce publication. Ethics boards are unfortunately very guilty. So I could speak about any of these stakeholders for more than 20 minutes, I think, and tell you why they are guilty. Unfortunately, I don't have the time. But trust me, funders, for example, they had the opportunity to enforce publication, but they just don't care. Why is that so? Well, of course, always human weaknesses. You have finished your project and are running for money for the next one, and if you haven't published it or if it has been sent back from a journal, you just don't care. So that's a very strong argument. Then many people have a deep awareness against transparency. They simply don't want, for example, universities. They're very interested if they have a low level of clinical trials in their university. They have a strong interest not to make that transparent, of course. And I can give you the examples. The strongest reason is probably conflicts of interest. Then you have legal games where people play with it. And most people have a very focused view. They don't look at the big picture and they don't see how these effects accumulate and in the end damage patients. And this is one project we run now. It's called Open. You see here, we try to reduce the amount of non-published results. And it's only for 2 years, it's 500,000, and all the stakeholders who are guilty are now part of the project. So in 1 year, they will have a big problem to explain why they are not doing certain things. Back to the picture from the beginning. In principle, we know quite well now from research from the last years that in principle we should speak about this world. What we do is, and everybody relies on that. For example, medical students, they learn, well, there's Medline, you go into Medline and then you work on what you find there. And then you work on this, and this is not a random sample of the real world, the whole picture. And that's a big problem. Very quick word about Cochrane. All I want to show you here is, you see here, this register. This is about 15,000 articles. The knowledge we have about the whole processes and the deficits are coming from these 15,000 articles. So these are methodological investigations. You see here that we know that the lower limit is around of RCTs in the world is around 600,000. Nobody knows how many there are in reality. So this is what we know, what we can touch. And you see that this summarizing questions, this process has led so far under the Cochrane roof to almost 5,000 completed systematic reviews. This is only 20% of what we have overall nowadays in the world. What we see here is strong support of methodological work, and again, coming back to this risk of bias again and again. That's publicly available on the internet, was published in 2009. And if you now come back to the overall theme of this Congress, if you look at drugs, non-drugs, for example, we have seen one Wonderful example, surgical procedure, acupuncture was mentioned before, but you can add a long list of interventions. Then you have medical devices. Currently very popular in a negative sense are breast implants, hip replacement, of course. The questions you should ask is always, if somebody tries to convince you that something works or is not harmful, and that's the way we do it, are there trials at all? So go down here. And what's the quality? So searching and finding is this basic principle. And then you go into context. And then you look at the whole set of trials and do it in a systematic way. And if you can fill these question marks reliably, then you are on a methodological level that you can try to trust the results. And that's the procedure. And the principle, the message is exactly the same as what Jürgen Windler said. There is no difference between what we see here. We have a fairly well-developed world with drugs. But if you go down here into this field, in principle, they should pass the same hurdles. So if you try to look at the big picture in medicine, most people are tempted to divide the world in two parts. And I absolutely agree with the previous speaker that the division of the world is not this way, but this way. And we should try to get as many of these interventions into this area. And if people are do cooperate, then we try to support them. Some people try to get away with many explanations why it's not possible, and you can't do that in our field, and in many cases you can't do the ideal procedure. But if you go back to basic principles, the basic principle of research is repetition. And if people decline to go that path, then it's not science. That's very simple. And second, to be able to judge what has happened, and you can read that very often in Nature and in Science, you have to be transparent, complete, and you have to make your results accessible. And that's the whole principle behind everything which does not work, what I've shown you before. What about anecdotes? I mean, I think all of you here on this conference are very often faced with anecdotes. If you look at anecdotes, you have in principle 4 situations. You apply a method, and then it may work or not. So then you're on this line, or it may not work. And then you may report it somehow, tell it to somebody, or write it up, and then you're here, in this case, or here, or you don't report it. And if you look at anecdotes, if you try to present it in that way, the anecdote is only filling the cell. But if you do a trial and present a trial, you need the information in those 4 cells. And that's a big failure of anecdotes. Most people don't think about that. Because if you want to calculate whether this procedure works, then you need the successes and what proportion are these successes of the overall number of participants. That means it's A divided by A plus B. So the whole number in here. And there's no way to get any information about it, because all you do in anecdotes is you celebrate this case. And you never go into the numerator. A few words about recent international developments where people try to pull all these strings together. The Lancet is one of the big 5 top journals in medicine, and what you see here is, that's an editorial 2 years ago, putting research into context revisited. This word here says that they also agree that things don't work. You see a box down here where they have advice, and you see here papers on randomized trials after the 1st of August 2010 contain a panel in the discussion as outlined above, and put the results into the context of the totality of evidence in the discussion. And that's in principle what I've told you before. So an article now, a report of a clinical trial, has to start with a systematic review and have a systematic review in the discussion list. That's more or less the think tank of the world. That was last year, and you see here, finding what works in healthcare, standards for systematic reviews, this which summarizes what I've described, and that's the same picture. They absolutely agree, there's no doubt about this approach to get full access to information. And Equator is something you may not know, but which is worth a look. This is a set of guidelines for publications. What should you write up if you write a report of a clinical trial? It's a checklist, it's a background paper across many, many different study designs. So most of you may find something helpful here in this case. To summarize, the overarching theme of this conference is knowledge, belief, and uncertainty. I think these concepts are just non-compatible. So there's no way to find a compromise. If you want to believe something, you have to believe it. And if you want to work on knowledge, that's just a different world. And I've been trying many, many times to find a way in between, but in the end I always gave up because I saw that there was no way to think about it in a rational environment. That means the proactive use and exploitation of knowledge needs full transparency, and that's a clash between knowledge and belief, because there's no transparency if you work on the belief side. And again, to summarize very briefly, uncertainty is certainly intrinsically all over the place if you work with knowledge, and if you believe, you try to avoid uncertainty as far as you can. So I think personally, and that's a very far-going summary, I try to avoid wasting time to change somebody's belief, because usually it's hopeless. So I try to fight those who abuse science to sell their belief as science. And that's something you may achieve, and I think that's, again, leading you eventually to the basic question, is a science a side or not? And then you are back to basic principles, and that's what I've tried to express during the last little bit more than half an hour. Thank you very much.
Thank you very much. So I'm sure there will be a few questions.
Alan McClintock, New Zealand. Thanks very much. That was a terrific talk. Thank you very much indeed. Over the last 10 years, I think there's been increasing ability to record automatically and electronically patient data. And that's been covered with the proliferation of easily accessible software to mine that data. So now you can't seem to pick up a medical journal without someone torturing the hell out of banks of data retrospectively. And that's a notoriously, well, it's notorious for picking up false positives, retrospective data mining. Do you have any concerns about the proliferation of this practice in terms of the validity of our medical literature?
Yes, very many. Because you run into all traps of working retrospectively, and one of the really bad developments currently is that people ask for registers all over the place. And then, because registers are very resource intense, they don't plan the registers, so they just start, then they are incomplete, and in the end, you end up with poor quality observational studies. And most people don't recognize that, because the current mantra is, we need a register, and the rest will come alone. And this is simply wrong. I fully agree, yes.
Do you have an estimate, or are there any known figures about what percentage of the non-published trials or studies have been submitted but have been rejected, maybe because they did not show significant results. So how relevant are journals in the whole problem?
Yeah, that's one of the intrinsic unresolvable questions. I can only argue on the basis of simple journals. So, for example, the Lancet has a rejection rate of, I think, around 92%. So it's a bit mad, because the quality issue is you need a high rejection rate, and this is increasing, all I've shown you. So in principle, we need something as a solution, but everybody is proud to reject as much as possible. And so, yeah, that's why in my list of people who are guilty, journals are in a very prominent place in there. So, yeah, and it's, the lower you come down in quality, the more they accept.
A question: as a measure against evidence-biased medicine, it has been proposed to actively retract papers, so to name and shame scientists where there is real proof that it has been ghostwritten or highly selective reporting. What do you think about this proposition?
Can you read? You mean to force people to reject?
No, to retract papers. So let's say it shows up in PubMed, it should be indicated that this specific paper has been shown to be ghostwritten or to have some bias or some poor scientific quality, because this would be, so to speak, a very dramatic measure for a scientist's reputation. So things might stop then.
I think I'm against it, because then you have to reject too many papers.
Okay, there's nothing left in PubMed, okay.
Yes, but there's no decision. You don't have a cutting point where you say this is ghostwritten or not, because there are just too many. And the relevant papers, all decisions in the pandemic plan of Tamiflu are ghostwritten, and it's obvious. So the first author has agreed that he has never seen the data. It's a Swiss guy from Geneva or Lausanne, and it's a very famous story, and it's very clear, and even parliaments ignore this knowledge. So the problem is much bigger. It's not a rejection problem.
Hello, my name is Yvonne Meyer. I'm from the Bayerischer Rundfunk, Bavarian Public Radio. So I work with language, and I'm really interested in the maybe non-difference between alternative and complementary medicine. Because when I report on homeopathy, colleagues tell me, but this is complementary medicine, it's not so bad as alternative medicine. They actually think it's only, yeah, you know. So how do I work on this? Because I think it doesn't really matter, because either it works or not. So for me as a reporter, it's a problem, and I get bad emails from people who say it's complementary medicine. So how could I approach this?
Well, I could invite you for a glass of wine if that helps, but Jürgen Windler started his talk with playing with these words, but people won't understand you. That's a problem. The solution is where I changed this red line, and it's about, is it effective or not? And it's not the problem what the name is. And people who try to push you into that direction, in the first second try to hide something. I'm very clear about that.
Okay, thank you very much.
The World Skeptics Congress, Paranormal, Supernatural, Fringe Science, Pseudoscience, and How It Really Is.
With skeptics.